Hi, folks. Welcome to CS128 Honors. Today, in this week's lecture, we're going to be covering data types and functions. Our goals for today are to cover the compound data types, the data types that we didn't cover last week, functions, and vectors in Rust. So, this is a rehash of what we talked about last week. What are data types? Well, data types are the method by which we tell the compiler what type of data it's looking at or reading. And usually these data types are built into the compiler so users can access these data types with predetermined keywords. And there are two primary types of data types, scalar data types and compound data types. Last week we talked about all the scalar data types, integers, floating points, booleans, and characters. This week we'll be talking about more of the compound data types, tuples, arrays, strings, and so forth. So tuples are fixed length boxes almost of data. They can store different values of different types, and you don't need to declare them explicitly, like you don't have to declare variables explicitly. They are immutable and they are zero indexed. And they're essentially set up in the way that you can see on the right. So here we have a tuple, which contains an I32, an F64, and a U8. Those of you who remember last week's lecture know that this is an integer of size 32 bits, a float of size 64 bits, and an unsigned int of 8 bits. And these values are respectively 500, 6.4, and 1. In this case, 500 can be accessed by using x dot 0. This is what we mean by dot notation. It's very unstandard and uncommon, so if you're familiar with other programming languages, this will come as a bit of a difference to you. We can see 6.4 as well, which is x dot 1, and 1, which is x dot 2. Empty tuples with no values in them are called units. They are the default return type for functions in general. So if we have a function, say main, in this case, function main, the default return here is an empty parentheses, an empty tuple, which is a unit. And its value and type are both just given as empty parentheses when you try and print them out or get the type of this value. We can see another example with the tuple here in the bottom where we say function main, let tuple equal 500, 6.4, and 1. And then we can see we didn't have to explicitly declare the type of this tuple. And then we can access the individual elements by using parentheses x, comma, y, comma, z, and we can print out each individual element. So y would be 6.4. The next piece of compound data types are arrays. Sorry, let me move my camera so this is more visible. Arrays are fixed length, unlike certain other languages, particularly Python, which uses lists. Arrays must also store the same type values. An implicit declaration is allowed, much like in the other types of declarations we've looked at. We can see one example of this on the right. We have let a equals 1, 2, 3, 4, 5. They are mutable by nature. You don't have to use the mute keyword, and they are also zero indexed. You can access elements using the square brackets, and invalid indices will throw a trace error. You can see exactly what different types of declarations look like on the right. You can see we have an implicit declaration here where we just say let a equals 1, 2, 3, 4, 5. And then we can see an actual declaration here where we say let a, we give a square brackets, the type, a semicolon, and then the number of values stored, so the size. And then we have our values themselves. We can also say let a equals 3 colon semicolon 5. And this declaration is essentially the value and the number of times it appears. So this allows us to create an array of size 5 with all values inside being 3. We can see our axes on the left where we say let a equal 1, 2, 3, 4, 5. First would be a0, which would give us 1, and let second equals a1 would give us 2. Next, let's talk about functions in Rust. Functions are conventionally declared in all lowercase with underscore separating words. This is called snake case as opposed to the camel case some of you may be familiar with in Java. This is also the standard in programming languages such as Python and C++, so it's good to get familiar with it right now. While it's not necessary, it is good practice to have. The order of declaration of functions in Rust does not matter, which is something that'll be very much a surprise to you if you're familiar with like Java or Python, due to the nature of how the Rust compiler works. Most other languages focus on going top to down in their compiler declaration, so the compiler goes from the top and starts compiling downwards. This means that if you use a function before it's actually declared, for example, in this case, print labeled measurements is used before it is declared, it'll throw an error because the compiler does not actually know what print labeled measurements is. But the way the compiler works in Rust is very interesting. Prior to the actual reading of the code, it goes through and it looks at everything and turns it all into machine code. So all of this is turned into some equivalent binary that represents each bit of code. So this print labeled measurements has a binary section in the memory that's associated with this particular function, even prior to its declaration or its usage. Then when we go in and actually call print labeled measurements, what happens is it knows exactly which piece of binary to access in the memory. So the main doesn't have to throw an error because it doesn't know what print labeled measurements is, because at this point, the binary has already been created. It's a very interesting niche and use of the Rust compiler that's interesting to know. And just a fun tidbit. The way you declare functions are with the keyword fn, which indicates a function declaration, and then you use these brackets to indicate a function body. And you can pass values into functions as a parameter. Parameters must have type declarations, and you cannot do like implicit declarations like we did before. We can see an example of this in print labeled measurements as below. We have our function with fn, print labeled measurements, value, colon, explicit declaration of I32, and our unit label with an explicit declaration of character, after which we can use those values inside our function as need be. Parameters do not need to have the same type, and they are by default passed by value and they're immutable, meaning if they're edited, changes are not reflected outside the function and you will get an error throw. You can pass mutable parameters and they can be edited inside the function, but this requires some interesting semantics in Rust based off of how the compiler works as I described today. So next, let's talk about parameters and the return values. So mutable and eventually ampersand and star are all part of the parameter type and have to be passed to the function for proper assessment of values. So you have to give mutable to indicate that it is mutable. And ampersand and star are both used for memory management cases. If you're familiar with C++, you'll understand that ampersand implies that we're going to find the address of, and pointer means that we're going to go to the address to the data that this address represents. And I'm sorry if that's a bit convoluted, but we'll go into more detail later. And you'll also learn more of this in C++ when you're taking CS128. Functions can return a value after their call. And all you have to do to specify what your return value is you give an arrow and then you give the type that you want to return. So in this case, we can see we have fn5, arrow I32. And you can only specify a single type to return at any given time. So if you want to return multiple values, you have to use one of the compound data types we talked about earlier, a tuple and an array. Another interesting thing is you don't actually explicitly have to say return 5 in this case. You can just say 5 because the way Rust deals with data, it implicitly understands that if you just have a single piece of data at the end, be it like a variable name or a piece of data like 5 in this case, it'll understand that this is implicitly what you want to return. And you can see we have fn main, let x equals 5, and if we print the value of x, we'll get 5. So vectors are not a type of data type that the compiler explicitly recognizes. And for those of you who don't know what a vector is essentially just a growing list of data. Does not have a fixed size, and it can grow as much as need be. It has much of the same constraints as arrays, though. They are inherently mutable. They are inherently uh, they have to have initial size declarations and initial type declarations. All of their sizes must be of the same length. And sorry, all of the data must be of the same type. And they are, as I said, they're inherently mutable, so you can do whatever you want with them. If you don't explicitly give them a size, they're defaulting to 0. So you can see here, let v vec I32, vec colon new. This inherently sets size to 0. And you can also use the macro for vec, vec exclamation mark, which also declares a vector. It's important to know that vec colon new and the vec macro are not the same. These are not the same data type in the compiler. So if you want to use them interchangeably, you have to use a transformation function, but both of them are indexed using the square brackets notation. So you can access one here with v square brackets 0, and this would be square brackets 1, square brackets 2. So this is a bit about vectors. They're going to be very useful in your programming. So, and especially in MP1. So please take careful notation of them and how they work. If you're familiar with them, good, because they're already used in many other languages and they behave very similar to how they do in Java or C++. So vectors, you add values to them using the push function. And you can see an example of this on the left. Let mute v equals vec colon new. v dot push 5, v dot push 6, v dot push 7, v dot push 8, and this will return us a vector with 5, 6, 7, 8. We can also declare our vector here, v equals vec with the macro 1, 2, 3, 4, 5. And we can see the third is equal to an ampersand of I32, ampersand of v2. These ampersands simply represent addresses. They aren't something you have to be too concerned about at the moment, but it's a good way of accessing data and just manipulating your data in general. If you want to get a particular element, you can use the square brackets notation, or you can use dot get. Dot get is useful because it returns an option, which is important because you have to unwrap these options and make sure that your data is in proper formatting. And it's just safer in general to use an option. You can, of course, always use square brackets, which is a very familiar way of doing it. So if you aren't familiar with dot get or with options in general, feel free to use the square brackets. And we can see another example in the bottom right where we just say let v equals vec 13257, and we just iterate through our vector. So that's all for today's lecture. Reminder that we'll have extra or 0 credit practice problems that are always open. Homework 1 is being released this week, and MP1 is going to be released at the end of this week. If you want to follow along, you can go to Chapter 2 in the Rust docs or Chapter 8 for vectors. I'd also highly recommend looking into options just because they'll become a topic that we'll talk about frequently. However, we'll go over it in a future lecture, so no need to worry about it if you can't do that right now. All right, I'll see you guys all next week then. Thank you.